So what I would like to do is, first I want to welcome all the participants and attendees. It's a great opportunity and honor for us to host this meeting. I'm glad our invited speaker is just joining right now. Dr. Chintan Amrit has just joined. So it's a great privilege to have our session, this session of educational applications of interactive computer systems. Is really appropriate field and it is expanding, getting a lot of prominence. So let's begin our session. We would like to keep the time and let's just move on. So I would like to welcome Dr. Chintan Amrit to present our invited talk on novel data analytic methods to improve burden estimates for wasting. And Dr. Chintan Amrit is an associate professor at the Department of Operations Management at the University of Amsterdam. He has completed his PhD from the University of Twente in the area of coordination in software development. Having started it as RSM, Eramas University, he holds a master's degree in computer science from Indian Institute of Science, Bangalore. In the past, he has worked for 3 years as a software engineer. His research interests are in the area of business intelligence, using machine learning, open source development, and mining software repositories. His work has been accepted in venues such as Journal of Information Technology, Decision Support Systems, Information and Software Technology, International Journal of Production Research, Social Science, Computer Review, Information Systems Management, Journal of Systems and Software, IT Professional, Journal of Software Evolution and Process, Environmental Modeling and Software, and among others. He serves as a coordinating editor of Information Systems Frontier Journal, as an associate editor of IHCI Journal, and is a regular track chair at ECIS. Let's welcome Dr. Chintan Amrit. The floor is yours. Please proceed.
Thank you.
You may unmute. Yes. And you may want to share your screen. I believe you should be able to share your screen. And you have about 30 minutes, so please continue.
So right now it says the host has disabled screen sharing. Could you enable it?
I don't know whether I have privilege. Let me see. I can.
At local organizers, you have to give us as a the privilege to handle. Yeah, right.
I'm trying to see whether I have asking PIN number. Whoa.
Would you local organizers?
Do we know the PIN number? Oh, sorry.
No, I think that would you local organizers tell that would you give us as making us as a host of this session, so that we can give that as that sharing authority. Also, now there is Dr. Amit is going to be present, so he have to authority to sharing the screen. So,
thank you. Now it's enabled.
Okay, great.
Okay, thank you for a wonderful introduction. That was very nice. And so today I will be talking about some work that we did with World-2 program. And this work was actually a collaboration between University of Amsterdam and Northeastern University in the US, specifically with the group of Professor Özlem Ergun. And so I am, as like Professor Prabhakar introduced, I'm associate professor at University of Amsterdam, so you can see me as the second name in this list. Most of the work in this was done by the PhD students Mayur Ghosh and Zora Razai from Northeastern University, and it was supervised by myself and Professor Ergun from Northeastern University. So that is the it is. So the idea behind this was, this was a work, which was sponsored by World Food Program, and it was for the northern part of Africa, where we were trying to identify and predict the cases of acute child malnutrition in children below the age of 5. The idea is that if we can identify these hotspots, so these areas where there is acute child malnutrition, then they can change their supply chain so that they can provide these regions with food, more food than required, or divert their sources when places are better. So that is the idea. So here you can see that this is a child being measured, the upper arm being measured. This is a scientific way of actually measuring if the child is malnutrition. So the upper arm is the actual measure. So what is wasting? So wasting is a technical term, a medical term, which basically means that it's an acute form of malnutrition for the child, and it increases the child's risk of infection and death. And there is one thing, okay, there are a few concepts here. So they call it incidence. And what is incidence is basically the factor that can actually change over time, right? So to know the amount of children that are being that are having a disease, or any population like COVID, the people having COVID, what they say is that they call that a burden. So that burden is basically the number of people at any particular point of time having that particular problem, medical problem, right? So if you want to estimate the burden over a period of time, you need to estimate not just the number of people who have got the particular disease at that point of time, but also those who have been cured of that. So you see what I mean? So it's actually a number of people who have got it minus the number of people who have cured. That will give you the actual number. So for all this, people have been using something called incidence correction factor in regions of Africa. They came up with a number which basically gives you this understanding of how many got it and how many were cured. So we thought that this incidence, and it's also well known in literature that this incidence correction factor is not very well decided. So therefore, our idea behind this research was actually to predict using machine learning techniques and using the data in the Sahel region to predict the amount of burden, to estimate the burden of acute child malnutrition in the region of Northern Africa, right? And here we mention RBD, which is basically the Regional Bureau of Dakar, where the World Food Program is. And they have the office there, and that's where we got the data from. So our idea is to develop machine learning models to predict burden of wasting. And we identified the important features that influence the burden of wasting. So basically predict wasting, number of people who, number of children who suffer from wasting. And then the idea is to compare different machine learning models and the current hotspot analysis, and then see how well we are doing related to that. So that is the basic idea. So what kind of data did we have, right? So we had hotspot data from kind of a lower level. So this is data that you see from on the first row, which is administrative 2 level data, and this gives us the number of children in that particular area having acute child malnutrition. The second row is basically nutrition level data, and we had this between 2012 and 2021. Again, at the lowest level, administration 2 level. So administration 2 level is something like you have states in a country. You have states would be something like administration 1 level, and then you have districts. And the districts are basically administration 2 level, which gives us a very more detailed data for that region, right? So this is why we are focusing on administration 2 level, because that gives us a more detailed data for that region. Then the third row is basically informed Sahel. So this is informed data, which is basically online data about the conflicts in that region and other kinds of publicly available information like the amount of rainfall and how well the crops grow in that region, right? So all this is informed data, and therefore these three different kinds of data we thought would be sufficient for us to predict. So this is also, we looked at other kinds of data, but we decided on these three, right? The demographic data that we had was basically total population between 6 and 59 months of the child. Nutrition data, we have something called SAM, MAM, GAM, the incidence factor, prevalence, all that, right? So, and then we also had the health data of the children. So we had the number of children who were suffering from diarrhea, malaria, deworming, measles, cough, and so on. So we had all different levels of data, but we also had data at for the demographic, nutrition, and health. So we did this. We looked into the hotspots that, because we had the burden data, we could look at what areas of Northern Africa. So if you see, when we call this now Northern Africa, basically it is this region where it includes Mali, Nigeria, Niger, Chad, Cameroon, Guinea, Senegal, Mauritania, and Mali, right? So I already said Mali, Burkina Faso, right? So these are the countries that we are looking at, and they are happen to be below the Sahara Desert. I think that's the region where it's very difficult to have sustainable agriculture because of the hot winds that blow in that area from Sahara Desert. So agriculture is very difficult here. And therefore, throughout the year, there is sort of a dependency towards food being delivered by other countries, right? And that's what World Food Program does. So if you see 2020 down here, the amount of hotspot, for the data we had, so there's a lot of data that's missing. So all the gray areas is data that is missing, but the data that we had, you can see that there are a lot of hotspots in the area of Mali and Niger, which are having severe acute malnutrition, but also in Burkina Faso, it's not very good, right? In 2021, we have more data, but then again, we see that the amount of hotspots is not decreasing. In 2022, we see an even higher increase of severe acute malnutrition, because this we think is because of course, having more data at this point of time, but also the reason could be because of COVID. The supply chains, the food supply chains had been affected, and this has caused even more acute malnutrition in Northern Africa and all over the world. I think COVID has caused a lot of supply chains to be disrupted, leading to severe acute malnutrition in children. And this can be seen, this is a phenomena that I think World Food Program is seeing across the world. It's a terrible thing, but that's the reality right now. Okay, so so we see that the current approach of World Food Program is to use prior literature to identify areas that have severe acute malnutrition, that what they call hotspot, and they use something called odds ratio. So basically, it's like what we use in logistic regression. They use this odds ratio to identify to decide which areas have more acute malnutrition kids than other regions, right? So that's the current approach. And what they're doing is they're not using real data; they're using published papers and studies on this. And then from there, they are identifying this odds ratio, and then they calculate that for the given amount of children they have in an area, they use the odds ratio to identify the amount of the burden of the severe acute malnutrition in that area. So that's briefly what they're doing. And what we wanted to do was we wanted to improve this study by using actual data and coming up with the machine learning models that can actually predict the acute malnutrition. And so that is our approach. So, so the data distribution that we had over 3 years is for admin 2 region, we had an increase, of course, and this is the amount of data we had. So we didn't have very large data, right? So admin 2 region, you see, we have 489 rows in 2022. At the admin 1 region, which is higher level, we had 92 rows, and the common regions had regions that are areas, admin 1 areas that are common across the years, because we have different amounts of data every year. We had only 37 admin 1 regions that are common across 3 years. So we had not much data, and the idea is, with little data, how can we still use machine learning to identify, to predict severe acute malnutrition in children, and is it possible to get reasonable accuracy for that with such small data, right? So what was our methodology? So we start with raw data, we do some data pre-processing, and in the data pre-processing stage, we do data cleaning, handle missing data, remove duplicate data, handle feature selection, and then after the pre-processing, we identify the usable data, and then we go ahead with supervised methods. But we also try to use unsupervised methods so that we have a comparison. We identify the target clusters, and the idea is, in the end, to develop decision support system. And that's how I think this research is related to human-computer interaction, because we, in the end, want to develop a decision support system that people can interact with to identify burden, the burden of the number of children with severe acute malnutrition. So the first set of algorithms we used was ensemble learning. So we used bagging and boosting. In bagging, we used random forest and support vector machine, and in boosting, we used the very famous XGBoost, which is, I think, one of the best algorithms that you see even in Kaggle competitions. And we also used LightGBM as a means of comparison. What we did was we used stacking. So we used a combination of these algorithms to find out how well we are doing. In terms of metrics, because this data, the burden data, is got from the different admin 2 regions, it is sometimes you can't be very sure about the actual value that we get from each region. So because of that uncertainty in the target variable, what we are trying to do here is trying to use one-off accuracy. So here, if you see at the bottom, we have, instead of your typical table where you actually see precision recall and your confusion matrix, we are happy with one-away precision and one-away recall. By that I mean that even if your class, your target variable is A11, we would be happy with A21 or A12. So either A12, A11, or A21 would be fine with us, because we are giving that little bit of slack there because of your uncertainty in the target variable. So this is called one-away accuracy, and this is one of the metrics that we use for our research. Okay, so going ahead, we see that empirical hotspot analysis classification was validated by country experts. And that validated target variable had some issues with accuracy, we think. So that is why we gave it, there was some noise there. So that's why we considered also one-away accuracy. So here we see the distribution of the target variable, low, medium, high. High meaning that there's high amount of burden in that region. So many children are suffering from acute malnutrition. And low is, okay, low number of children. So, and very high is the last bar. And there you see everything is growing in 2022, because the regions are, more regions are suffering from acute malnutrition. That's what we think. Okay. So, so how do the cases compare, right? So we used our algorithms to actually predict acute malnutrition, and we can see all the different cases on the table where we combined the different burdens, SAM, GAM, MAM, and GAM. So what do these mean? SAM is severe acute malnutrition, MAM is moderate acute malnutrition, and GAM, GAM is global acute malnutrition. So these are terms, medical terms used by World Food Program. Severe meaning really high, moderate meaning medium, and global is the overview of that region, right? So each case we try to predict all three, and we see that our test accuracy is not very high because, okay, we had not very good data, not much data. We are looking at small data sets here, 400 rows and things like that over 3 years. And the other reason is that there is some noise or some little noise in your target variable, which is causing this lower accuracy. So that is why we used one-off accuracy, but if we use one-off accuracy, we get very high results, 94 to 97% accuracy. But remember, this is one-off accuracy. So we are happy with one away from the target variable at both sides, right? Like we show in this matrix down here. Okay, so that was our results. As I explained, one-away accuracy is is high, 90%, but exact accuracy is only 50%. So what we did now is we tried to bin the target variable, and after binning, we saw that we are able to get even better results for the different cases, right? So it is of course fluctuating, but some cases we get up to 74%. So for case 5, we are getting 74% exact accuracy, right? But this is after looking into common regions and binning the target variable. Binning means we put them into 4 or 5 bins, and that makes the data better for classification. Okay, so one other technique. So we wanted to see all the different techniques we could use with this small data. And one more thing we used was unsupervised clustering. So we use unsupervised clustering using very simple k-means clustering to first create bottom-up clusters from the target variable. Why did we do this? Because we were not certain about the amount of noise we are getting from the target variable, right? So that is why we wanted to see what is the data showing us. Apart from the noise from the target variable, if we just cluster based on the different features, what does the cluster show us? Okay, so then we get these clusters from k-means clustering, and most of you might know what k-means clustering is. So it's a way of clustering based on distances of the points to the neighboring points, right? So we made our clusters from k-means clustering, and now we try to predict those clusters using the data we had. So we got basically 4 levels of data: low, medium, high, very high. And then we tried to actually predict those 4 labels that we got from clustering using these features. So we get the clusters from the features, right? And then we use the same features to actually predict those clusters. It's a bit circular, the reasoning, but I think it's interesting in this case because we can't be sure about the target variable. Okay, so the first one which we see is unsupervised versus priority. So here we see that we actually can compare what we get from our clustering approach to what we get from priority, the labels that we had of the burden. And we see that we are doing like better with our prediction, right? So this is just a comparison of the 2 data sets. And if we actually try to predict the regions, we get about 85% accuracy trying to predict the clusters that we generated, not using the actual target variable given by World Food Program, but by using our own target variable by clustering, right? So we get quite high exact accuracy and even higher 93% one-away accuracy. So that is what we did. And so in general, when we have these 3 cases. We have the priority level validated by country clusters, which is the actual target variable we got from World Food Program. We use these, we saw that these are the important features from there. So the prevalence, that means the amount in that region of severe acute malnutrition, is one of the features that we actually get. So actually we can drop this feature because this is directly correlated with our with the severe acute malnutrition. But the health features that actually help us are access to health structure, diarrhea, and the informed features. So these are features about the overall region that actually affect this is food insecurity, droughts, aid dependency, food security, malnutrition in human, the amount of humans that are there in that region. So that is what we were, that's the kind of features that we got were important to predict the actual target variable from World Food Program. But for predicting severe acute malnutrition of children only under 5, the features that were very important were mortality rate, access to health structure in terms of health features, but in terms of informed features, there were hazard and infrastructure. So what we did is, and here nutrition features, we see SAM, GAM, MAM prevalence, as well as stunting rate, which is basically the rate at which they are not growing. So we can actually drop these features. So that's what we did in the unsupervised clustering. Because they are highly correlated with our target variable, we dropped them, and then we see with creating our own target variable, these are the main features that we found important. The amount of conflict the region has. So how amount of wars that are going on in that particular country, how stable it is, aid dependency, malnutrition, food security, droughts, and health conditions. So these were the important things. But also the health conditions that deteriorate the health are malaria, amount of malaria they have, access to health structure, and other, I think IDPs are other health problems for small children. Okay, so basically this was the results. Accuracy of the current hotspot analysis against priority levels, we got about 40% accuracy, direct accuracy. One away accuracy was 90%. That means we are not worried about its exact, but it's one away from the exact class. Accuracy of machine learning algorithms with new and existing features was about 50%. One away accuracy was again 90%. Accuracy of SAM U5 target prediction was 70%. Okay, so this was a direct accuracy. But then when we did our own clustering to find out the target variable, we got very much higher accuracy of 85%. And across all predictive models, we saw that the predictive power increases when the regions that have data across all years are considered. Prevalence features are included. And what we found, the most important features are generally prevalence and nutrition related, followed by the informed data, that's data about the region, where it is about the amount of conflict, amount of crops growing there, that kind of data. But also the deterioration data sets help us understand what diseases the kids are having, which actually affect the severe acute malnutrition. Like if they have malaria, it's a very high chance that they also suffer from malnutrition. Okay, so future work that we plan to do is we plan to collect more consistent data across the years, so more data, consider additional data representing the impact of global events on local food, analyze global commodity flows, so understand the global supply chains, build models estimating supply chain risk, and explore algorithms to explain the data-driven predictions apart from Shapley analysis. So we use some Shapley analysis also, or SHAP analysis. I haven't shown that here, but okay, that's I think also interesting. Consider prescriptive and analytical models to make robust decisions for planning and operationalizing interventions in the presence of forecast uncertainty. So that is one of the things that we plan to do. We want to see how we can prescribe better predictions, right? And develop information infrastructure for data collection and storage processes. And one other thing that we want to do, which could be also interesting for the human-computer interaction community, is actually use better interfaces to collect data and also to analyze the data on an analytics dashboard. So the first thing is about these apps that can help you collect data from the ground. And this is essential because I think the current data collection of World Food Program is not optimal. And it relies on different countries for collecting data. So that was it. So if you have any questions, please let me know. And any comments, suggestions are welcome. Thank you.
Thank you very much, Dr. Chin Armit. Do you have any questions for members? Do you have questions?
I just want to tell Dr. Amrit, this is an excellent introduction, and we are all getting to know how much it is important, how this data analytics is applied to Northern Africa and their nutrition program, and how to make it effective, where data collection is difficult. I may ask you one question that in case of when you do supervised learning, how would you label, or how would you assess the correct one so that you can compute the accuracy? I understand you showed the formula for accuracy calculation. In order to obtain it, you will need to, for a supervised learning, you will need to have a specific the labeling. How would you do that?
Yeah, so that's a very interesting question, because that is what we also were struggling with. So we had a lot of data, and the data itself had labels. So we had, for example, I'll show you, sorry, the initial data set. So, oh, by the way, our code is available online on a GitHub repository. So if you're interested, please let me know. So the labels that we had were are kind of given here. We had labels at admin 2 level. So we could see how many children had severe acute malnutrition, the number for the different admin 2 levels over from 2020 to 2022. So we actually had the actual number for every region. So we had 489 rows of data at the admin 2 level. So here we can see, for example, some district in Nigeria, we can see, oh, this region has these many children, like the number of children with severe acute malnutrition. We have the actual number. And we also had the number of children with mild acute malnutrition and number of children with global acute malnutrition from those regions. Same region, we had all three numbers. So that was the number that was our target that we were trying to predict, right? One of the numbers that we were trying to predict. But there was another label that was let's say, having some noise, which was not related to this severe acute malnutrition number. It was the burden level that was given by the regions. So each region has kind of a government where they actually can give a number for the extent of severe acute malnutrition. The number is between 0 and 5. They give a number. Like if they say it's 4, they think that region is suffering with a lot of children with severe acute malnutrition. So that is what we had, and that was our target. And because it was a number given by the government person, it was having a little bit of noise in it. So that is why we had to look at bottom-up clustering to identify the exact values for that region. Yeah. So thank you for that question. This is what we were doing.
Thank you. Oh, thank you for your excellent presentation and bringing us an awareness about the application of AI for critical people who they critically need it. So it's an excellent presentation. Thank you. As we have run out of time, so we may not be able to accommodate other questions. So we'll begin with paper presentations now.
Thank you.
Do you have any questions? And thank you for your presentation, Dr. Chin Armit. And next speaker is 1041, Shahzad Alim Alamardon. Are you ready?
Yeah, I'm ready.
You can share screen and start presentation.
Hello, thanks for letting me present our paper. Can you hear me?
Yeah, here.
Thank you. Our paper is called Implementation of Virtual C Environment is 3D Wave Animation. And I developed this paper with the help of my professor, Chong Yupil. And so I will give some introduction and discuss some my background, and I will talk about the implementation and the results and conclusions will be given at the end. So the problem for of our paper that we are trying to solve is that today people go to whale watching tourisms. They go on ships in order to see whales on the surface level, but it is not that common. Oftentimes people come back without seeing whales, even though they spent a lot of money and they spent some time, but actually seeing them is a lot harder than people imagine. So we are going to develop a virtual tourism that we will create some special environment that people can go in and have the experience of watching whales on the surface level in the comfort of wherever they want. Maybe it can be their home. They will sit in home and they will get some gadgets like a virtual reality headset, and they can experience the whale tourism. And then virtual tourism like have a lot of advantages over real tourism. Like it is much more accessible for people. Like in Uzbekistan, it is a double landlocked country, and it is very, very, very hard for people to travel to overseas to some sea to see the mammals, and it is very expensive. Like they have to buy very expensive plane tickets. This is also a very problem, and a lot of people will not have this luxury to travel and see people. But virtual tourism, as I said before, can be experienced at their home with some pretty cheaper virtual reality headsets. And also we want to decrease human presence in the vicinity of whales, because if people go near to whales, they will get disturbed and can be damaging for them. So we think that if we let them alone, if we don't go near to them, they will have more enjoyable and free life. So our paper will also we are also trying to help environment by creating alternative solution and giving whales more freedom. So here I will talk about the background. If you see the oceans, if you see how waves are generated, there are mainly two forces, like big forces. The first is being wind, and the second is gravity. Oftentimes, wind will disturb the ocean surface so that it will generate waves, and then gravity will restore the disturbed ocean surface. So in this paper also, we only use wind to disturb the ocean level, and then we use the gravity to restore them so that we can simulate the oceans. So in games, in the computer graphics, waves oftentimes simulated. If you see the animation, there will be only plane surface, and this plane will have vertices. You can see yellow dots. Yellow dots are representative of geometries, vertices. And then the trick is we give them circular motion. Each one of these vertices will have circular motion so that it will look like that we are generating waves. This is the main approach that we are going to simulate ocean waves in the computer graphics. So this also will be the main method in our paper. Ocean generation includes a lot of computations. A lot of times we need to move from time domain to frequency domain or vice versa. If we use discrete Fourier transform, it takes very large computation complexity like O(n) square. But we in this paper we used fast Fourier transform, and we decrease the computation complexity to n log n time. There is a very huge change in the amount of computations. This is the main spectrum, main algorithm in our paper. It is Jones-Watt spectrum. This spectrum will give us the spectrum of waves. We give some variables, like we give wave speed, and we give gravity acceleration, and we'll give fetch, and then this algorithm will return us the spectrum of the waves. You can see on the diagram there are different wind speeds, and Jones-Watt spectrum have generated the waves and the wave spectrums. We will use this spectrum to simulate ocean in our paper. By the way, Jones-Watt spectrum is developed on the North Sea. People wanted to predict that the amount of the speed of wind, how much waves will certain amount of wind speed will generate at the end of like when waves near to the shores. They wanted to predict the height of the waves. So we can also use this in the computer simulation. As I said, like this is the 2D representation, two-dimensional representation of ocean simulation, but we need a three-dimensional. So we also need X, Y, Z displacements of the ocean. On the right side, this is the full formula. I didn't include this, but you can ignore them. Only you can see that we will have displacements for all three axes, like y-axis, x-axis, and z-axis will all have displacements, and then we will give circular motions to all the axes, and then we circulate every point on the our plane. So implementation, for implementation we use Unity as a main game engine. Inside Unity there is compute shaders. Compute shaders is very suitable for large computations because it is carried on the GPU side. So a lot of the heavy computations is on the GPU side. Like you can say Jones-Watt spectrum will be calculated on the GPU side. And we also calculate directional speed, T correlation, and inverse fast Fourier transform. These are all heavy computations. And then we get all the data and send back to the C#. And C# Unity C# script. This part, we generate ocean geometry, like the vertices, like yellow dots on our simulation. And then this ocean geometry will have a large body. And we get the data from compute shaders. We generate the ocean geometry on C#, and then we send this to the Unity standard surface shader. This is also a type of shader in the Unity, and it mainly deals with displacement of the vertices of our ocean geometry. And we will apply a color, and then we apply the form application. All of the compute shader data of compute shaders in C# scripts will be applied and simulated in the Unity standard surface shader. So a very big part of the ocean simulation is about the foam generation, and then it is very problematic to predict the foam generated points. But fortunately, there is a very very good point, very good indicator of foam. Like you see, when we generate the displacements, this displacement sometimes will make our geometry upside down, or like we generated plane will get upside down, and at that point it gets breaks. In real life also, when oceans water goes up and breaks down, there will be foam, so that we can get the exact point that via ocean foam, the wave foam generates. The actual point is taken by a Jacobian determinant. We will get the Jacobian matrix, and we get its determinant here on the diagram. You can see that this green dots are actually the results of Jacobian determinants. When Jacobian determinants is minus, it is below 0, you can see that there is breaking waves, like our geometry getting upside down, and it means that there is waves that is breaking. They are breaking so that we can apply the foam, so that using the Jacobian determinant we can detect the breaking waves and apply foam.
You may have 2 minutes to wind up.
Yeah, 2 minutes. Okay.
Yeah.
We also added animals like whales, dolphins, and a lot of other animation models to create the virtual environment. This is the result of our simulation. You can see this is wind speed at 10 meters per second. The waves are big and very agitated. This is the more medium sea surface level. The wind speed is 4 meters per second. The waves are still agitated, and they have a very big waves. This is a nearly very calm sea surface level. The wind speed is 0.1 meter per second. Very calm sea surface level. In the future, we also would like to add some other features like a water splash. At the moment, we couldn't achieve it because it requires a lot of computation complexity, but we are working on it, and hopefully in the future we will create a water splash as well. Yeah, thank you for your attention. If you have any questions, I'm ready to answer.
Thank you for the presentation. Are there questions from the audience? Both in person and virtual. Are there any questions? Yeah, I just would like to ask one general question. It's extremely interesting that you're using Unity to generate this, simulate the entire ocean wave. I understand it's a lot of calculations needed, but I just want to know, are there different equations to apply the wind speed? How many different theoretical equations that's available to simulate ocean waves, and how did you choose the one for your implementation?
Yeah, basically, ocean simulation is mainly about the heights of the waves. That the thing that I showed you earlier, like Jones swap spectrum, there are a lot of different algorithms for generating the heights of the waves. Jones swap is just one of them. Why we choose the Jones swap? Because it generates the spectrum with waves that the waves will be more like it's the, how can I say, the shape of the waves is more like realistic in our experience. In our experience, we created more realistic one using this algorithm only, but there are a lot of other options. that can be implemented. We just like visually, we just like Johnson spectrum. That's it.
Perhaps you might consider if there are some data about wind speed and the coastal line, the other parameters are available, such as hurricanes at different places that's happening all over the different. I don't know how tsunami could have been taken into account. If then the parameters are available, might be perhaps you may be able to simulate and show what could have been the wave of those places. That is maybe difficult to capture with a video camera, at least you could show them, model them. But we appreciate it. Thank you very much. So let's just move on to the next paper. So we will be, I would like to know the next paper in this moment. Try to bring paper list. Co-creating computer-supported collective intelligence in citizen science hubs. This presenter, please, third paper, low-cost entry-level educational drone with associated K-12 educational strategy. I see that Bailey Weimer is available. Welcome to the presenter, and you will have the screen.
So you can share the screen right here. Yeah.
Hello, can you hear me?
Yes.
Okay.
You have 2 minutes, and I will give you a signal after 2 minutes to go. Thank you.
Hi, my name is Bailey Weimer. Today, I will be sharing with you a low-cost entry-level educational drone with an associated K-12 education strategy. My co-authors for the paper are Justin Danamiller, Saifuddin Mahmood, and Dr. Jong-Hoon Kim. We are all part of the Advanced Telerobotics Research Laboratory of Kent State University. So to begin, we designed the ATR drone system. It's an educational tool primarily for classrooms targeting the ability to educate children of any age. With that education, it targets programmatic thinking and robotics concepts, and it does so through the use of abstracted levels of control. The system is a 3-tier architecture. Those 3 tiers are ATR Scratch, the ATR Linker, and the ATR Drone. The first, ATR Scratch, is a front end through which the user is able to code and control the drone. The second, ATR Linker, is where the bulk of the development was done. This is a middleware program. It's responsible for communication between the other 2 layers. And then finally, the ATR drone is an open source, custom designed drone specifically for this project. Along with this, we also developed an education plan. This education plan hinges on the idea of splitting students into different levels based on their age range and their grade in school, allowing students to learn incrementally over several different years, all using the same drone and the same drone system. Our motivations for this project were pretty simple. Going forward, as technology advances and as we see a rise in robotics, they're becoming more and more prevalent and more necessary for day-to-day life. Because of this, we need proper education to ensure that future generations are able to maintain, build, develop, modify, and create and design these robots that are going to prove to be so necessary for day-to-day life. Additionally, research has been done that shows that students benefit from hands-on education in classrooms. And one of the ways to facilitate that hands-on education is in the form of robotics. So robotics can be used to teach other STEM subjects besides just computer science and robotics. And when it's done, when that hands-on method of teaching is performed, educators have found that students perform better in classrooms, they pay more attention and are more interested in what they're learning, and they're more likely to behave well for the educator. In the past, research has shown that drones can be very beneficial towards robotics in classrooms, but unfortunately, most of the drones used in those studies were lacking substantial features that really limited the practicality of their use in classrooms. For example, this first paper that I have listed here is talking about a drone known as the Pi drone. This was a drone that they designed using a Raspberry Pi. It found a lot of success in their class. They taught a high school level class using it. And it was very successful. It had a very good outcome, but unfortunately, it didn't take into account the fact that there are younger students who want to learn and who would be interested in robotics and drones specifically. Additionally, the drone used in that paper turned out to be moderately expensive, which can be a limiting factor for educators, especially given the low budgets in areas where this would be the most beneficial. The second paper here is a paper released in 2019 by our lab. And in that paper, we discussed a drone that was usable for college level education. Once again, we found a lot of success with that drone. But overall, drones tend to be very expensive, and they don't, the classes that are used to teach with them don't tend to target students below the high school age. So in order to fix some of these issues, we have a 4-step method proposed. The first part of that method involves prioritizing the safety to ensure the well-being of not only the students, but also the educators, the property in the classroom, and the drones themselves. Second, we intended to design a system that allowed students of any age to learn from the same drone. So what that means is a student who is brand new to computer science is able to learn from the drone, but a student who is also familiar with computer science can learn from the drone as well. We also intended to create an education system that prioritizes that incremental learning. And finally, maintaining a low cost of materials was a high priority for this project as well, to reinforce that accessibility and just ensure that anyone anywhere is able to learn from or teach using this drone. To enact those plans, we have 3 system fundamentals, the first being abstracted design. So basically, as I mentioned earlier, students are split into levels, those levels being L1 through L4 that I'll get more into later. But at each level, these students are provided a different, more complex set of controls. With that more complex set of controls, they're expected to have to gain a better understanding of more advanced level robotics and computer science concepts. Additionally, the open source nature of the project was a high priority for us. Both the hardware for the drone and the software that run it are intended to be open source, which provides educators with access to the technology much easier and the ability to delve deeper to give their students a better understanding of what is going on behind the scenes. And finally, safety. Now, this is where we pull from that last paper that our lab published in 2019 that I mentioned earlier. In that paper, we discussed a gyroscope, which allows us to attach the drone to a metal apparatus to lock its motion horizontally. So the first part of the system is the education system. The students are divided into those 4 groups, L1 through L4. And each one is given access to a different set of controls. Now, as you can see on that bottom table there, along with that, they're given robotics objectives and computer science objectives. So this stems anywhere from just learning basic visual programming at like a very basic level, all the way up through at the highest level, potentially building a PID controller completely from scratch. Now, the system itself, this is a representation of it. So the data flows, the user interacts directly with Scratch, ATR Scratch. ATR Scratch then passes that data onto the ATR linker, which parses the data and converts it into controls for the ATR drone. The ATR drone then senses data that it needs to sense and sends that backwards through the system so the user can process that data. The first part of that system design is ATR Scratch. So this is a modification of an open source software known as Scratch. Scratch is maintained by MIT, and it's an open source visual programming interface, allowing students to use the blocks that you see on your screen to learn programmatic thinking and logical problem solving. The blocks that you see on the screen are actually our modified custom built blocks that interact directly with the drone, which is different from standard MIT Scratch, which only allows users to develop software without any hardware integration. The ATR linker is where the bulk of the development happened. It's a middleware program that runs on the user's computer, and it's responsible for communication between Scratch and the drone. And it facilitates that communication in two ways. Between Scratch and the linker is an HTTP protocol that we developed. And then between the linker and the drone is our custom-built ATR Bluetooth protocol. This Bluetooth protocol it primarily focuses on being very lightweight and very small message sizing to allow a high transfer rate of data. And that high transfer rate of data is crucial due to the third aspect of the ATR linker. So normal drones are controlled by the drone board itself. What this means is that in order to maintain balance and maintain proper flight, all the calculations that need to happen on the board of the drone. What's different about our system is those calculations actually happen within the ATR linker. So that allows us to have more precise control over how those calculations are done. And it allows us to give students who are learning more access to see how that works and to modify or even build their own PID controller to work with the system.
Yeah,
finally, the drone. The ATR drone was built on a custom 3D printed circuit board. It houses everything that's needed to fly the drone, a microcontroller, a battery, a USB-C port, and it can be seen on the right over there. It also has that gyroscope that I mentioned in the middle, and you can see on the left the metal apparatus that it attaches to. How that works is it locks horizontal movement, so it can only rotate, but it can rotate very freely in many directions, and it can move up and down. Additionally, for safety, the drone is equipped with a fail-safe landing in case of a disconnection from the ATR linker. And the drone is very, very cheap to build. We actually found at the time of our research, we were able to build the drone and the safety apparatus for around $40. On the left here, you can see the schematics for the printed circuit board. At the top right is the design of the board, and then the bottom right is the physical board itself. So in terms of results, we did a stress test of the communication system between Scratch, the linker, and the drone. We found that between Scratch and the linker, we were able to sustain over 1,000 messages per second. And between the linker and the drone, we were able to sustain around 1,400. This was done using our custom-built protocols. And we calculated that for a PID controller to be implemented in Scratch, we would need right around 30 messages per second. And this well surpasses that number that we would need for that. In the future, we'd like to expand the ATR linker to be able to work with a whole suite of educational robots that we're designing. Additionally, we'd like to add more control methods to the linker as well. We do need to finish a full implementation of the system on the hardware using all of the aspects that I described in this paper. But once that is complete, we would like to perform a cross-sectional study of subjects ages 6 through 18 to just verify the educational method, and see how that works in practice. In conclusion, the ATR drone helps bring robotics into classrooms, and the fundamentals of the design and the system structure can be applied to many other robots in the future. If you have any questions, here are all of our emails. You can reach out to us, and I'm open to take questions now.
Are there any questions from audience? It was a nice presentation, and I really like this idea of bringing inexpensive, at the same time beneficial way of bringing the linker, and as finally you have a three layered approach. It's extremely interesting. At the same time, it's feasible to using a Scratch as the front end. How many? Is there anything has been actually tested, and have you built it and put it on a real setup, and how is it? Is there any experience or feedback you have learned from deploying?
Sure. So the bulk of the results come from this slide here. The getting that communication nailed down was extremely important for our concepts moving forward. Proving that this system of communication works is very valuable for expanding the linker. And it will allow us to have, especially using Scratch, to have more complex controls that normally you wouldn't be able to have in such a simple programming interface that uses visual programming and has that abstraction away from complex text-based languages, which would generally give you a deeper level of control.
I was trying to find out practical testing within a real world of this product. And did you receive what was the response from the participants?
I apologize. I'm having a very hard time hearing you. Give me just
one
moment.
Sorry. Okay. I just want to make sure that in a real world, if you deploy this system and what was the feedback you're receiving from the participants, that would really help us to take it to the next level. You can say this is deployed in at least 1 or 2 level, and how the participants have really thrilled about it, or how much that's I'm asking about some case studies of deployment.
We did only that as a lab test only, because of the previous
the
previous one version in 2091 we did with the the college students, but at the time we don't use that as Scratch is connected. So we want more lower level, so that we just focusing on how to interface in that Scratch.
So that
Sorry about that. I believe I'm having some audio problems on my end.
That's fine. Well, thank you for the best presentation, and I really like this idea. It will be taken to mass scale. It's scalable. That's another thing. Yeah.
Thank you so much.
You're welcome. Let's move on to the second paper, and the presenter, can they come forward? Thank you. And I hope Dr. Alita has control. Are you able to share the screen? Go ahead, please. You have 12 minutes to go.
Go like this.
Yes, we are able to see that. Yes.
Okay. But I cannot see myself. So it's okay.
No.
It's okay. Okay. So good morning. So I am professor from Vilnius Gediminas Technical University in Lithuania. So I am teaching in Faculty of Communication and Creative Industries. So I try to be short because I see the audience is a little bit bored, and then it is very sunny Saturday morning. So, but maybe I could say some interesting things which will be important for your future or for your studies. So I will present today a project which we implemented together with 4 other universities, co-creating computer-supported collective intelligence in Citizen Science Hub. So this, so the project is about Citizen Science Hub. So I don't know if you know anything about citizen science. It's a very new approach which we implementing now in European Union. So research implementing together already with pupils in school, with students together, and starting already by designing research and implementing and using different digital devices. For example, measuring air quality or water quality or other environmental factors when citizens collect data and processing data together with researchers. So we implementing this project in 4 countries: University of Twente, Netherlands, Vilnius Technical University, Lithuania, Aristotle University of Thessaloniki, and University in Barcelona. So you can see all 4 countries, and each country has very unique regional challenges, different scientific agendas, but we try to establish this hub at universities and involve students from very beginning in the research. So I don't know, students from which faculty are today here? Okay, computer engineering, okay. So I'm a social scientist, and always is a problem between social sciences and computer scientists and IT technologies. This human-computer interaction is very important for us, because technologies, they are only not on themselves. They should create some additional value for society. And when IT experts working together with social scientists, always are better results when they work separate or doing something like that. So by establishing these hubs, we met different problems. So first of all, we did a lot of research on how to establish the hub, which technologies we could use, how would be the best way, to involve, to motivate, and to establish these hubs. So our methodology was in-depth interviews, large-scale survey. We made different surveys and exploratory studies. So this is about our questionnaire structure, barriers, drivers, willingness to join, general information, and things like that. And we developed such theoretical framework, on which we will establish our citizen science hub. I would focus your attention on following things that you see here: wisdom of crowds, and you see here human-computer interaction, you see actors dimension, content dimension, process dimension, you see also different levels like micro level, meso level, and macro level. So you see different stakeholders involved. So, and then different technologies also involved. So we wanted to see and to how all different interactions between different actors and where content will be created, how we manage processes and things like that. But I don't know if you know the approach, wisdom of crowd, or collective intelligence. So it's very important for our hubs to create conditions for collective intelligence to emerge. And these conditions are very specific conditions. So for collective intelligence to emerge, we need critical mass of users. Then we need independence and anonymous voting. Then we need also some collective decision-making technologies and other things to be involved. So we first created this theoretical framework. Then we made some research on that, where, what, and how to implement, and we made some conclusions about it. So here you see these actor dimensions, which I mentioned, process dimension, content dimension, then different actors who are involved, like government, citizen, business, NGOs. Then you see these micro, meso, and macro levels. So maybe I not talk too much about this because they are only frameworks which help us to design then later software, hardware, and other things. But maybe I explain a little bit more about what are social technological conditions that led the communities to be more intelligent. So how technologies could help to create some social value, or how, for example, when you create some, I don't know, network, community, website, how to make this network more powerful and more successful. Yes. So what should be, which technologies and how to use them. So first of all, they have to be clear, introduced, and easily mastered, technologies which use. They have to be designed to pursue specific goal and represent the goal. So it should not like sometimes computer scientists, they just create something which is very interesting from design point of view, but it doesn't have a specific goal. So why are you doing this? Why this technology which you use? What is the task? What it will be what value it will be for users? Then it should be encouraging diversity of opinions by providing privacy, anonymity, and personal data protection. So you need to create technologies which could include as more possible users as possible. Then it should have knowledge accumulation and exchange of information technologies. Yes, so you have not only provide technologies which let you share information, but you should create also like distributed memory system. You should collect that information which you have, and that information should be available in your system also for future. Not only that is discussion, we exchange information and nothing happens next. This information should be processed and also stored in your system. Yes. Then you should have collective decision-making tools like collective problem solving, virtual brainstorming, voting, ranking, and things like that, because collective intelligence is not only when we share information. Collective intelligence when we have structured opinions, when we have problem-solving methods, but it's not only sharing information, but coming out with some conclusions after the discussion, you know, because for example, on Facebook or other networks, we have a lot of different discussions, but nothing happens next. So we don't have long conclusion from that discussion. So if you apply like collective decision-making tools or collective problems tools, ranking, voting, virtual brainstorming, so it then you have some already structured opinions, some, you know, some decisions or some outcomes of your discussion. Yeah, also special attention has to be paid to different gamification technologies, and also before presentation was about, for example, virtual tourism. So it's one example of also gamification technologies which could be introduced also by establishing citizen science hubs. So when we can say that community is collective intelligence, so when we have diversity, flowing of new ideas, and so when we have different users from different generations and from different, for example, languages and from different demographic units, so you should create the possibility to for different users to get to your network. Then anonymity is very important as well, so that people could vote anonymous. That then, for example, your teacher opinion should be not important for you. You should present your opinion, and you should not know who is voting for what. You know, when voting, it should be anonymous, because independence is very important for collective intelligence. That you don't have social influence from other participants. Then, of course, decentralized structure and governance. So it not should be like one centralized point in hub like that. And of course, synergy is based on swarm effect. So collective intelligence emerges only between people. We have all our own individual intelligence, but collective intelligence emerges only in groups. So it's what groups have, not a separate person has. So by establishing hubs like that, it's very important to create these preconditions for collective emergence to emerge. And as I said before, so memory system like that stores information and knowledge, intelligent problem solving, and of course, it's very good or success of community like that in case it exhibit higher level intelligent capability than any community member in separate. So the task maybe of such hub is to connect machine intelligence and human intelligence, and to be more clever, more smart, and help people to solve different social problems. So that's it. Thank you very much.
Thank you. Thank you.
Thank you.
Are there any questions?
Also visit our website, so where is our project. So
thank you. Are there any questions to the presenter?
I have a question.
Yes.
First of all, was very interesting presentation. Actually, I have two questions. First is, how do you collect that kind of big data?
mhm.
I think it may occur some problem during collection, right?
Yes.
So, and the second is about your platform you implement this system.
Mhm.
This platform already has hardware, also software.
Yes.
For implementing, for example, for software, did you use some kind of some platform, or you create your own platform?
Yes, yes. So a collection of data, so it's so we usually researchers, they design protocol for collecting data, and then it will be collected through mobile phones, through different sensors. And so usually we collect a lot of data, because when people, for example, when we ask all students of your university to collect some data about, as I said, like water quality or air quality in your city. So we usually receive a lot of data, and
So
then
some kind of search engine, right?
yes.
Okay.
And after we have researchers who processes this data together also with students which are involved. And of course, it's more interesting for students start already with research like this in very beginning, when they designing together all the projects. And if you visit our website, which you can see now on the screen, so you can see a lot of different projects, citizen science projects, which are already working in different countries. So it's more like 500 different citizen science projects, which already are very successful. For example, in Germany, they did one project with the whole city, because they have a river spray in Berlin, and they started this project. It was a very dirty river, and they asked citizens to help to clean this river together. And everybody had a device how to measure the water quality in different places. And they did that project. And after 1 year already, they identified where, these places where the river is most dirty and why, and things like that. After 1 year already, Spree River was clean, and they made like swimming championship in that river next to Museum Island, so it was so clean that people could swim already in that river. So you should only, together, for example, I don't know for example, what is the biggest problem for Tashkent city? Which problems do you have? Do you have like air quality, or I don't know, or traffic, or things like traffic? Yes. For example, it could be one, you design together with social scientists, with transport engineering and other, and you try to solve this problem together, not like researchers separate, sitting and doing, but together with citizens, with students, with other peoples, and look for ideas, what you can do on that. And also for each project, usually we create like different platforms, or there are some platforms which we use together. But for example, for this project, it's a new platform which we can use, because all European projects are open source. So you always can go and try to do something. You will find all information, and it's for society, not just like separate. So if you want to join some of the projects, you always also can write me, and we maybe can do something together. Okay?
Thank you.
Oh, great.
Thank you. Thank you. Thank you.
Thank you. Thank you.
And now let's move on to our third paper presentation. So our third paper is equal temperament and just intonation feature-based emotional predictions in Carnatic music. Can the presenter come forward?
Mhm.
Is it Professor Vasudevan or?
Dr. Prabhakar, let's move on.
Let's move to the
Yeah.
final paper on this list. Design of a mixed reality-based immersive virtual environment system for social interaction and behavioral studies. Sophia, please go ahead, please proceed.
All right. Hello, my name is Sophia Matar, and today I'll be sharing the proposed design of a mixed reality-based immersive virtual environment system for social interaction and behavioral studies. The co-authors for this paper are Alfred Shaker, Saifuddin Mahmoud, Jonghoon Kim, and Jan Willem van Klossner. This paper is the result of the collaboration between the Advanced Telerobotics Research Laboratory at Kent State University and the BMS Lab at the University of Twente. The advancements in immersive technologies allow us to create more sophisticated environments designed to help engage users by merging the physical world with the digital or simulated reality. These can range from completely immersive virtual environments to mixed reality immersive environments, where the virtual world and the real world collide. Virtual reality is a completely immersive environment where the user's reality is replaced with a simulated environment. And the hardware works to convince the user that they're in a completely different world. In contrast, augmented reality is a mixed type of reality, combining the virtual and the natural worlds by augmenting the real world with digital assets and components. Immersive technology has a very high potential for future research, especially collaborative research for social interaction and behavioral studies. Any virtual space can be created with immersive technology to help develop the research. Although with virtual collaborative environments, a limitation and sometimes an inconvenience is present with the requirement of wearing a head-mounted device. It creates restrictions that prevent the user that prevents the users from having physical interactions with each other. Rather than interacting in the virtual space, this research proposes a concept that provides a structure for a physical space where users can interact with the shared mixed reality environment. And the environment is projected to help create the collaborative aspect of this project without having the users wear any wearable devices or headsets. Previous systems have been developed to include multiple people in a virtual experience by projecting a virtual environment on a physical counterpart. Other systems were able to help create an immersive space by having the user's hand gestures control the virtual system. We hope to contribute to this field by creating an environment where multiple users are able to share a virtual environment and interact with the virtual environment using simply their hand gestures. For the system to be fully implemented, though, it needs a physical space where it can be tested, where it can be projected and tested. And for this project, the Blank Lab in the Design Innovation Hub at Kent State University is the counterpart, is a physical counterpart. The Blank Lab functions as a black box environment for investigating collaborative experiences that bridge the scope of immersive technologies, including augmented, virtual, and extended reality tools. The lab has special hardware and software to ensure that every project can be projected in a uniform manner. The aspiration is to support group experiences of up to 15 people, regardless of whether the users are engaging with AR, VR headsets or experimenting with projections to create a cave-like experience. Yes, and using the different softwares in the lab's computers, the various projects can be manipulated as needed, using scalable displays for the syncing of the 9 projectors in the lab, and using Pro Tools for the syncing of the 15 speakers in the lab, creating a uniform sound and a uniform screen. This was one of the critical challenges in this project, that the proposed system should run all its interactable features and immersive virtual environments under the restrictions of both scalable the software, scalable displays, and Pro Tools. The proposed goal of this project is split into 3 sub-goals. First one being using the Blank Lab to project and implement this the virtual environments used in the system. The second being having multiple users interact with the shared mixed reality environment in the Blank Lab. And then the third, encouraging connection through a shared immersive experience, since users won't have the limitation or the restriction of having to wear the headset, so they're able to interact with each other. The ATR virtual environment system is a mixed reality based immersive virtual environment system for social and behavioral studies, designed to create a collaborative virtual environment in a physical space, the Blank Lab. The ATR virtual environment system has 2 main systems, the first one being the ATR immersive virtual environment server, and the second being the Blank Lab system, which has 2 subsystems. First one for the software of the video and audio systems, and the second one, the hardware of the video and audio. 2 virtual environment softwares were used to help test this application. The first one being provided by the BMS lab, and the second one being developed by the ATR lab. The ATR Immersive Virtual Environment System is a system that combines both the audio and video systems in the Blank Lab with our server. The ATR Immersive Virtual Environment Server helps create an immersive environment where users can interact with the virtual environments without the constraint of needing to wear a headset or the limitation of having to experience the space alone. The system architecture for the ATR Immersive Virtual Environment System, the ATR Immersive Virtual Environment Server will be processing all the input from the cameras or the camera in the Blank Lab to ensure that the projected scene and ground projections are fully updated with the correct scenes as the user is interacting with them. The current system is under development and is focused on implementing an immersive collaborative physical space for virtual environments. The work will continue towards the implementation of a software that configure any virtual environment, helping it build a completely immersive space. With that said, there was a main challenge that we had to overcome for the application to be presented correctly on the screen in the ATR lab. As mentioned before, the Blank Lab has a uniform configuration that each project must follow. With that, the Unity game engine couldn't create a field of view wide enough to create a project that would completely use the wraparound screen in the lab. Since the screen has an aspect ratio of 14,506 pixels by 1080 pixels. To combat this challenge, we had to manufacture both a camera system and a display system in the Unity application to help expand the field of view. The first step of creating this the correct field of view needed for the blank lab is having the background of the environment set as a panoramic view, which is then displayed on a sphere in the application. 5 cameras are set at the center of the sphere, each facing a different direction, with a set field of view of 72 degrees. Collectively making up the 360 degree field of view needed to create a field of view wide enough for it to be projected onto the screens without any type of distortion. The feed from each camera is then displayed on an alignment of screens, which are aligned correctly for them to be able to making the camera feed fit for the large screen. Since the application is projected on a sphere, the view is misaligned since it's not projected on a flat surface anymore. So using the cameras and the screens in the Unity application itself, it helps create the field of view needed for a large flat screen, similar to the one in the blank lab. So the human-computer interaction engine will be used to help update the surrounding screen and the ground projection with the respective scene as the user is interacting with the environment. The human-computer interaction engine uses the feed from the motion tracking module as well as the audio detection module to help generate the needed audio and the correct updated scenes for either the ground projection or the wall projections, the wall screen projections. As mentioned before, there are two virtual environments that have been used to test this system. The first one from the BMS lab, which is the Virtual Nature Healing Environment, which is a software created with the means of healing using nature. With the virtual healing environment, the user has the ability to design and experience the virtual environment of their choosing. The second one is the virtual harmony, virtual music therapy developed by the ATR lab. And this virtual therapy system was developed to help reduce anxiety and stress by allowing users to listen to music and play different instruments in a 3D environment with a real-world video as their background. So some design considerations would be improving the ground projection module mentioned before, as well as adding and developing a audio response module where users would be able to create a sound, for example, clapping or yelling, which triggers the respected response from the software. And to continue the development of this project, the application will be tested and configured with different devices, for example, laptops, phones, and VR headsets. And this will be to help discover how increasing immersion in virtual environments could affect human aspirations through various test surroundings with a diverse demographic. So to conclude, using the ATR virtual the ATR Immersive Virtual Environment System, participants can implement any virtual environment to create a shared immersed experience. The ATR Immersive Virtual Environment System helps provide an essential foundation for users to experience any environment they choose in an immersed manner. Thank you. And for any questions, comments, or concerns, you may contact me or my fellow co-authors.
Are there any questions for the presenter? I have one interesting question. It's an interesting idea. I really like this approach of having immersive technology. I just want to know if the virtual environment space and the physical lab size, if they don't match, we will have some distortion. That may be some difficulty. That's maybe one question. The other important question is, in the virtual space, when you have some solid object, and in the physical space, if a person is moving into the location or maybe trying to bring something into that neighborhood, how would you compute a feedback so that the user knows, yes, I'm moving on the space, it is not right, that's blocking, and how do you provide the haptic or some kind of feedback from that? And I know it's in the implementation, but I want to know, how are you planning to do that in the future?
I apologize. Could you repeat the first question, please?
Oh, the first question is about the variation, the difference between the physical space dimension to the immersive, to the virtual space dimension when they're mismatched. Mismatch mean if the immersive space is, let's assume, 10 meters and the physical space is only about 12 meters. So that kind of, how do you accommodate that variation?
So currently it hasn't been fully tested, like with the with like having someone use it. We just tested. We have completely tested the screen projections, making sure that it looks right or correct. So, but for creating, I guess we'd have a set grid of where the user is able to move about and interact. And depending on the environment and the objects in the environment, some would be blocked off, or like some areas would have been blocked off to allow the user to interact with the environment correctly.
The other important consideration that it may require a lot more effort is in the virtual space, if we have some solid object, and in the physical space, you're trying to bring another solid or a person trying to move into the space, they need to have a feedback saying that that's not possible. Already a solid object is there, now you're trying to put it in, that's not, I can't squeeze it in. So that calculation of the geometric volume and the intersection or interference, that needs to be predicted. I think you may be planning on that, just to want to know what's your approach. Well, thank you for your presentation. We may move on to the other papers. Yeah, sorry.
Dr. Professor Basu and Dr. Nagamani is here right now.
Yes.
So I think that they can presenting that paper number 6734. So
Equal temperament and just intonation feature-based emotion prediction in Carnatic music. Please proceed. Are you able to share the screen?
Hello everybody, my name is Abdulghani Muhruddin. I work at Zahidi Muhammad Babur named Anjan State University in Uzbekistan. My article theme is digital processing algorithms of biomedical signals using cubic basis splines. And in this article, the issues of digital processing and restoring of electroencephalogram signals from biomedical signals are considered. The locations of 21 sensors in the ego apparatus along the brain, the meaning of the sensors, their connection types, the use of bipolar computing in the detections of disease symptoms, interpolation of received signals, disease symptoms. During this work, the B-spline function was selected as the most convenient mathematical model for digital processing of ego signals, and the construction of the B-spline function was presented. Today, extensive scientific and research work is being carried out in digital processing of biomedical signals. We know that all organs of our body are controlled by the brain, that hands and feet determine the principle of working of all our internal organs. Electrochemical impulse detected from brain issues take the form of different type of waves. Their location different depending on specific areas. Currently, many devices are equipped with sensor as shown is the image below. You can see image. The EEG device sensors have bipolar and monopolar connections. In many cases, monopolar connection hides the initial symptoms of the disease, that is, the low frequency signals. Taking this situation is account, we choose bipolar connection in our work. In this method, the sensors are connected in series. You can see this picture, and we can see construction of the cubic base plan functions and constructions B-spline, and these formulas 1 and 2 is describe B-spline functions. And then the figure above shows the graphical presentations of the signals frequencies detected by sensors T3 to T5 and O1 to T5. Such an image make it easily to identify disease in the brain issues, but it takes a lot of time isolate the intervals with disease symptoms as shown as a figure. We know that it's important to diagnose and treat patients in a short period of time. Algorithms for ego signal segmentations and reconstruction using mathematical models are good to solve this problem. Below is the algorithm for identifying disease symptoms using B-spline. And you can see algorithm, this picture is described. Then the digital processing of ego signals is described the algorithm in which the parts with an amplitude higher than 120 are recorded separate in arrays SIM1, SIM2, and SIM3, and their values are restoring using by the selected B-spline. On the basis of the above mentioned algorithm, the parts with disease symptoms were separated and their values are restored. In conclusion, the table describes the absolute error, and the absolute error in EEG signal recovery was found be 0.0070, and you can see use B-spline functions. This will be help doctors to diagnose patiently correctly. And thanks for watching.
We had this video recorded as we didn't have authors presenters on the paper number 9399.
And Dr. Nagamari and also Professor Basu is here. And so any audience have some questions, maybe you can and ask to the presenter.
Professor, shall we connect?
Yeah, yes.
we can
Please
hear
go
you.
ahead and share the screen.
Okay.
Yeah.
Sir, our screen is shared.
Yes, we see the screen. We see your screen. Maybe you can make it magnified.
Okay.
You may start a slideshow, perhaps.
Yes, sir.
So actually, good afternoon. So we are going to talk about the impact of equal temperament and just intonation in Indian classical music. So generally, like, I wanted to meet it there.
Sir, we are from the University of Hyderabad. Dr. DVK Vasu sir is a musician as well as a researcher in the music industry, music in academic research. And I'm the faculty from Computer Science Department. In collaboratively, we are doing this work. This is mainly the work is understanding of Indian music and how the transition of Indian music way moving towards the westernization, because the music parameters when we take it, ours is a
just intonation scale.
Ours is the Indian music is the just intonation scale, whereas the Western this thing mostly in harmonics and other thing equal temperament kind of thing. So how our Indian music and the changing from the just intonation to towards the equal temperament kind of thing because of the electronic instruments usage in the music and new trends in the music changes. How original Indian music moving away from the just intonation is the main concept of our studies, sir. And we are trying to explore through software analysis is the basic our approach. It's the beginning of our work, sir. Yeah.
Professor Basu, as actually we have the little bit running out of time, trying to present a little bit the speed up.
Yes, sir. We will speak.
You may
Yeah,
start the slideshow, perhaps. That
Yes,
will-
sir. This is about.
yeah, it's like our human body is like a musical instrument expressing numerous frequencies and rhythms in constantly changing spectrum of life. It responds and resonates in consonance with music, sound, speech, and thought from the environment, and undergoes changes like of heartbeat, breathing, chemistry, and circulation of energy in various energy centers of body. So healing and relaxing music to release stress in body and mind based on the ancient sacred music of India is also part of the practice of Indian music.
Just
So
one
if we
second, sir.
look at that, Indian music has, we can say that has been neglected a lot when we look at the perspective of music research and signal processing and interdisciplinary researches. So we do a lot of concepts, but we don't know what is happening technically inside. So this study is talking about the actual frequency variation in singing, that how it is going to change from time to time, and the basic division of music like equal temperament or just intonation. So where we are, where our Indian music is, the study is all about that. So yeah, so why are we doing this study? Like Indian music follows just intonation scale. Means what is just intonation? That we are going to explain you now. Western music follows the equal temperament scale. So actually from one octave or a stage or sthayi is like from when you double the frequency, like if it is 200 and 200 to 220 is called 200 to 400 is called one octave. So this octave is divided in two types. One is like in the formula of equal temperament, and one is in the formula of just intonation. So just intonation is like it's not actually formulated. It has been naturally evolved. Even in the West, in India, everywhere, people used to follow only that naturally evolved music scale. As per that, only they used to practice music because there were no technology there. That's why whatever naturally has been evolved, that is more natural. But when you see that, you can understand the octave here. An octave is a set of frequencies in the range of x to 2x, like x is 200, the 2x is 400, where x is the first frequency and the 2x is the last frequency of the set. That means octave first frequency to the last frequency. So x is called the base note or adhara shruti in music. The choice of x depends on several parameters like the instrument, gender, age of the vocalist. Like sometimes the x can be 200, sometimes the x can be 180, or x can be 300. Depending upon that, the 2x will become the double of that particular note. Okay. So the music and signal process investigation in Indian music. So we have been using different technical instruments, technological instruments like Shruti box or music softwares. So those softwares are actually developed on the basis of equal temperament. So we have been using them, and we have not been monitored by any kind of technology in Indian music. So we are just this experiment is to understand that where we are actually. Is there any impact of these instruments that are actually developed based on the equal temperament having an impact on Indian classical music performance or not? Or naturally only we are moving from equal temperament to just intonation? All these things we would like to explore.
Just
So
moment,
we can see that the
Professor
major
Basu?
two.
Professor Vasudevan, I think maybe you can advance the slide, because right now we see only the first page slide of all the time. Okay, can you advance the slides? Because I think you are addressing many things.
Okay, sir. We are moving towards the results part kind of thing.
Would you show
it's not the time. It's you are not. The screen is showing only the first page. Maybe you are sharing a different screen.
Sir, we are presently on necessary study on the proposed concepts.
No,
correct, but it's not showing on the screen. The display is not.
Oh, I'm sorry.
Maybe.
I think you are sharing a different monitor.
Right.
Oh, yeah, sorry, sir. Sir,
Okay.
is it visible our screen?
Yeah, now I can see the necessary study on proposed concepts. Yeah.
Oh, I'm sorry, sir. These are those this thing. We just
Are you able to see the slides
Yes.
now?
Yeah,
Now
can
we
able
are
to
seeing
see
the slide.
Make it slide larger. Now it's 80% percentage size.
can
Can you increase that size?
Here you can increase the volume.
Yeah, that's right. Then
Yes,
now we
that's-
can just print that way, right?
Yes.
It's
this is
okay.
visible, sir.
Yes, we can visible. Yes, go ahead.
Okay, I'm sorry.
So actually, we are only interested in two things, like how we divide the scale in Indian music. Like if it is Sari, Gama, Padani, there are 7 notes and they are called Saptaswaras. And except Sa and Pa, remaining 5 notes have 2 differences, 2 variations. That's why in one octave there are 12 Swarasthanas. So if we take x equal to 200, 2x will be 400. In between, there are 200 frequencies, but we need only 12 Swarasthanas that are used for music, creating music. So how to take the 12 Swarasthanas? There are 2 ways. One is a just intonated scale, which is, just a second, one is just intonated scale, which actually evolved naturally, that has some formula to divide this 200 to the frequencies in the scale. Another one is equally tempered scale. You can see the formula of that base note frequency into 2 n by 12. So that is the formula for equal temperament, and just intonation has a different formula, like each and every note has a different fraction. So these are the 2 ways. Why previously the West and the India, everywhere they used to follow just intonated scale because there were no technical instruments. But slowly West moved to the equal temperament because of these reasons. Like West actually followed 2 principles. One is like harmony and dynamics. So dynamics talks about the volume, and the harmony is like playing 2-3 notes at a time. So like if you see in this picture, like if the notes are equally tempered or equally spaced in an octave, so if they play 3-4 notes together, they exactly match with the other note and make a nice chord or nice harmony. That's why they have created that equal temperament formula, and they have been using that. But in Indian music, we don't have that kind of necessity to. We're not completely dependent on harmony or dynamics. Like that, the just intonation frequencies are similarly like this. Like there is no equal gap between the notes. So here you can see that if the C is 1 by 1 and the C sharp, the next note will be 16 by 15. Which is not exactly as per the equal temperament formula. 9 by 8, 6 by 5, 5 by 4. But for equal temperament, the formula is the same. Like the distance between the next note from the previous note is the same for all 12 notes in an octave. So this is the actual important thing. Like as per equal temperament, the spaces between the notes are same, and just intonation, as the spaces between the notes are not same. That's why it is naturally evolved scale that we have been following in Indian music. But we wanted to know, because of all the technical instruments what we are using in Indian music industry to record or to Shruti boxes and all those things, if they are developed by the equal temperament formula, will they have any impact on the performance or not? That is the actual experiment. So the next thing is like, where is this one? Yeah. So we can see that the equal temperament base note frequency is 2 n by 12 base note frequency into 2 n by 12. That means if 220 is the base note frequency into 2, 1 by 12 is 36.67. Like that, 220 plus 36. So you add 36.67, you will get another note. Like that, this is the formula of equal temperament. Next slide. For just intonation, it is different. You see the ratio like 1 by 1, 220, 16 by 15. 220 into 16 by 15 is equal to 0.67. Previously in the equal temperament, the value is 256. So there are some 10 to 15 frequencies difference as per the equal temperament and just intonation scales. So now the actual experiment is like, understand, we have taken instruments and also vocal samples like violin instruments and mandolin, and also vocal samples of the artists, and we try to extract the signal from their performances through MATLAB and try to understand that, point out the exact frequencies like sa as per what they have sung. What is sa? Is it 220, 236, 247? Like that, we manually mapped those values of all these performances, like violin performance, mandolin performance, and also vocal performance. By doing that, what we wanted to do is that we know as per sa, one note 220 is there, and as per equal temperament there is 256, and as per just intonation it is 236. So and what actually played, so we wanted to compare the note the played by in the performance to check whether the note is equal, close to equal temperament or just intonation. So like that, we have taken all the notes, and you can see in the table, like first 329 is the base frequency, and next re 346, and as per equal temperament it is 351, and the difference between equal temperament and just intonation is 5.37. So like that, and what is being played. So what is the difference? So we have taken like that. If you see the graph here, you can see the first one is just intonation and equal temperament, and the last one is what is the note actually played. If you look at here, most of the times the sa, you can see the first one sa, there is no problem because it is equal, like higher sa also like that. And sometimes panchamam, you can see the pa is also close because there are natural notes. But if you look at the other notes, you can see either the actual note is close to the just intonation or the equal temperament. This is about the violin. But if you look at the next thing, it is in mandolin. You can see that the note sometimes close to the orange one or sometimes close to the blue one. So like that, we have given the frequency difference between this equal temperament and just intonation, and also whether it is close to the just intonation or equal temperament. So this is about violin. This one is violin. So mandolin. So yeah, in comparison, you can see that all sa, pa, sas are actually close. You can see here, and remaining things you can see that the actual note is either close to just intonation or equal temperament. So what we observed finally is that equal temperament and just intonation scale, by experimenting with various Indian instrumental and vocal music, found that in case of primarily instrumental music, the compromise is little. What does it mean? Like when we are comparing the signal or performance of the violin and the mandolin, so the compromise is little means as per the natural way they should be close to the just intonation scale. Means they are not compromised much towards equal temperament. They are close to just intonation. We are still able to manage in the just intonation. But when we compile the vocal music, the compromise is more. That means the vocal music frequencies are actually close to equal temperament than the just intonation scale. So this will means that what kind of effect we may get by doing this. Like they may be performing in the same way, but there is an internal difference of notes, what actually they have to sing and what they are singing, because we don't process the signal every time and in a concert to check each and every note. For a long time, like hundreds of years, we have been singing it. So it may be possible that we may change from one temperament to another temperament, or you may be in between that. But sometimes when we are using these instruments, that may be another reason of this change. Or sometimes even in for medical or some therapeutic aspects, if the note is too pure as per the just intonation, it may be have more impact and proper effect. So these kind of things we have to actually work. So like same experimentation can be done in different ragas, and we can create Shruti box and technological softwares to record music that are developed as per the just intonation, and give it to musicians and ask them to use for 5 to 6 months and see that whether there is any change. So that if there is any change, then the impact may be because of those kind of using those kind of instruments. And how to use pure scales. Just intonation is one pure scale, so naturally evolved to get more listening effect, more psychological satisfaction and understanding about music. So this is very very new subject, and people, they don't think that there are two kinds of octaves are there in dividing the octaves, equal temperament and just intonation. So sometimes many musicians also, they don't know and not sure about the technological people, how they look at it. But this is a fact that there are two scales. One is just intonation and another equal temperament scale. What we are choosing will also have a difference to make for the listeners. So thank you.
Thank you very much, sir. So this is because we are working on 72 basic ragas kind of thing. And sir is a data source who is creating the data. He is playing the music instrument as well as vocal. So that was our preliminary research work, sir. Thank you very much for giving opportunity. And we thank to IHCI 2022 team, sir. Thank you.
If they have any questions.
So kindly, any questions or suggestions?
Are there any questions to the presenters? Yeah, I'm really interested in the way you are presenting the whole approach of two different scale system, temperament and intonation. I just want to know if someone has, I understand from your presentation, intonation seems to be the more natural base. And if that is so, if someone is presenting a temperament-based notes, like you see lots of music notes written in Western, they're all coming in a temperament scale. And if they're in temperament scale, is there a way to translate? I know may not be your immediate one. How to translate temperament scale music note to intonation scale, so that someone experienced in intonation scale, they can play that Western music?
Yeah, very, very interesting thing, sir. Actually, see, when we are playing a keyboard, so keyboard is a tuned instrument that has been developed by a Western company like Yamaha, Casio, or something like that. So they have the formula like equal temperament, and they actually program that chip as per the equal temperament only. And the same thing, though, if we see, the problem is that as a Carnatic musician, I would like to sing like Sarigama Padanisa with the help of the keyboard. So the keyboard sounds sound like equal temperament, and my sound is also altered towards that. So another what you for that, like as you said, that if the company would like to change the formula in the keyboard, so we can create a keyboard that is as per just intonation, that can suitable for Indian music too. And even the Shruti box and all those things, it is a simple formula, but they are not aware that this should be developed for Indians. And there are a lot of Chinese music and all those places, they also use just intonation. But sometimes unknowingly, the equal temperament is rubbed on the minds of the people without their knowledge and without the producer's knowledge. So that is the thing, but it is a simple formula. The main problem, even the movie musicians and Carnatic singers or Hindustani singers or players, they go and sing in a recording theater, and that has been recorded as per Pro Tools or Logic. That Logic has been developed as per the equal temperament. When they auto tune, their all notes will be auto tuned to equal temperament. They sounds very unnatural. So actually, if it is some problem that one, it is a project, some these companies can look at it, and if they can have an option in their tool saying that record as per equal temperament or auto tune as per just intonation, so we'll give the results. And a lot of harmoniums are there, sir. In Carnatic music, in Hindustani music, they have scale changer harmoniums as per the frequency. Harmoniums are there. If they use, then it will align with the proper intonation. But there can be a software that, as you said, that if they sing in just intonation, and it can be converted into equal temperament, and equal temperament can be converted into just intonation. But it's not so easy for a human to exactly go and sing the just intonation particular frequency in that range. So there may be a 4 to 5 frequency difference that they will be able to catch.
Thank you.
Great.
Thank you.
Thank you.
Now, Dr. Kim, is there the other paper?
No, I think this all paper was presented. Yeah, there was actually that
Video?
The video that's just before that this presentation. So we
Can
all
we stop sharing, or is there any questions, sir?
I think there's no more questions. Yeah, there's no more questions. Thank you.
Thank you very much, sir.
Thank you very much. So we will share our email ID, and if there are any more questions, they can just share. We are very happy to answer. Thank you, Kim, Professor Kim. Thank you very much. Thank you, Nagarajan garu.
Thank you.
Namaste.
Welcome.
So finally, that I believe we presenting all, actually one papers was not able to present in this moment. So we will notify the organizer to what should be the next. So Professor Prabhakar, maybe would you wrapping up the session so that we can finalizing up this?
Yes. First, I want to thank all the presenters and the keynotes and the invited speaker, Dr. Amrit. So this is excellent idea of sharing a diverse topic from a three-wave simulation to all the way to music. So it's a great opportunity for you, and this is our last session on this conference. So thank you all for joining this session. We will conclude this session with this message.
So final is going to be award ceremonies in 1 hour from now. Please, that is, if you can join and see that what that value of that award is go to someone, and hope that is some of that our presenter will receive that award. I wish that, and let's join the final ceremony, and then we meet at there then. Okay. Thank you.
Thank you all. Bye.
Bye-bye. There's a proper, I think that we have maybe small that maybe email to that organizer saying that is because one paper is didn't present, right?
So the
Also,
IHCI, the person with the part that they are there, so we can talk to them directly.
Yeah, you received about the video that response back saying that is one paper is not present, and original paper 734 was presenting in our session, so notify them.
I see. Okay. So can I put them on the message right away? Let me send it to the IHCI.
Yeah, just email that we received for the other video, right? That yesterday or early yesterday, right? So maybe response back, and then just because there's all that organizer email in that that email. So
7364 is being presented, a video presented, and the other paper was one is missing is 93.99. Not 93.99. Yes, 93.99. 93.99 is about a recommendation system in an e-learning platform.
Yeah, right. Just reported the presentation was not even given, even since we don't have a video, so we couldn't even present. So.
Okay. That's fine. Okay, we will conclude it. In the chat, they may not be able to respond, but let me put it clearly.
Okay. Yeah.
For session 10.
Right.
For session 10 on according to the date, is it October 22nd, right?
Right.
October 22nd. The paper 93.99
Will not presented.
is not presented. However, another video for another paper. Paper 7364, right? 76 was played.
Yeah. Video presented at our session.
Video was.
Thank you for the local organizers for helping us, and it's a typical situation that is the one that was in the local. So yeah, it's going to be end session. So right now we're trying to wrapping up that report to that as organizer. So what was presented, what was not, then basically the session is over. So thank you very much for helping and us to learn these sessions. And
thank you, Professor.
Thank you very much, all of them.
So we put our message on the chat about these information to you. Yeah, please look at the session that I mentioned about paper 93.99 was not presented. However, a video for another paper 7364 was played in this session.
Yeah, so those information we're going to report to the email too, so that our session will be wrapping up. And I believe that is this all that session was the recorded, right? So that recorded video will be, because I believe that it still is recording. So I think that is the entire thing. We send that to the organizers. They will be making a video, that recording and aggregating on their side. All right, and Dr. Prabhakaran, thank you very much.
Yeah, thank you, Dr. Kim. I will send an email to them.
Nagarajan garu, I think we missed your talk. It's on our it's on educational education.
Oh, I didn't have a presentation on today. I didn't have any presentation. Only yesterday or 2 days back, I have presented on the quantum computing.
I'll be happy to interact. I have shared the number and email. If you have, then I can be.
Sure. Definitely we will discuss.
Actually, we missed, sir. We thought we will join in Tashkent. Somehow we could not join.
No, I'm working remotely only. Sorry, I was I'm not in Tashkent. I was just remotely in Florida. But this is time is 4 a.m. here, 4 a.m. in the morning. Yes. So that just the interesting idea. I thought instead of your musical one, instead of instrument redesigning for the different octaves, if there's a musical note for a vocal in a Western, which is the equal temperament. I believe some, as you suggested, I think you mentioned there are some software that's available to translate from a equal temperament to equal intonation. And it may be something if somebody goes in a Carnatic music experience, if they want to play or sing or vocally sing the same Western note. And if there is a translation from equal temperament to equal intonation, simple conversion tool.
A function can be developed by any software person that, so if you given the signal that arrange those notes as per the equal temperament or just intonation, vice versa, they can it can be translated actually. Not sure about the tool because this concept only the people technically who is a sound, they only know about that equal temperament just intonation. Sometimes musicians also, they don't know what they're playing. It is as per equal temperament just intonation, they don't know. So they just sing, they just play.
Sir, I think, sir, one Western musician and Indian musician together has to record the data, and we can observe actual what is the thing, and then we need to develop some models like a deep
It may
learning
be
model.
interesting to have two different musicians, Western and classical, in Indian classical musician. If they have a combined concert, if both of them
Yes, sir.
present at the same time, that will be, this kind of challenges will appear. How
Yeah,
they synchronize? How they synchronize?
we can do that. I think I may be visiting USA in the next April 2023. I also told Professor Kim, if possible, we will do some experiment or some program
Sure,
there.
sure. Let's plan out sometime that now there is
Otherwise,
getting late.
sir, 2023, one complete music concert can be arranged in the IHCI 2023.
All
So
right,
that we can
yeah.
have a data record.
Yeah, right. I believe that is in the ceremony of that Korean ceremony, they will announce about the next venue. So maybe we can see it where is going to be goes to that next venue. Then maybe we can plan out something in future.
Thank you.
Thank you very much,
Kim.
Professor.
All
Thank
right.
you, Professor.
Thanks, Narayan Garu. If you have email ID, you can just share there. You can.
My email is there. I think it's very straight. Just my last name at fiu.edu.
I'm not able to hear.
No, my last name. My last name at fiu.edu.
Okay.
My last name, FIU, Florida International University.
Okay. Okay.
Thank you, Professor.
You're welcome.
All right, then let's finalize and then have a wonderful day and see you at the Korean ceremony then.
Yes, Professor,
Yes,
we are
thank you.
joining.
Thank you.
Bye. Bye.
Thank you. Bye bye.
Namaste.
Thank you.
Thank you. Bye bye.
Bye bye.